Hello everyone, I am Forrest from FLC Technology, designer of FLC8s in-ear monitor. Based in China, FLC Technology LLC is committed to developing and producing high-end in-ear monitors and custom in-ear monitors. In 2011, we were one of the first companies in the world to launch a hybrid CIEM. Since then, we have maintained our position as the leader in hybrid IEM technology. And our years of hybrid CIEM experience have allowed us to develop a super hybrid IEM with excellent crossover technology. FLC8s is a hybrid IEM with one dynamic speaker, two balanced armature drivers. It has an excellent sound, precise frequency response. It has a solid bass. It's airy with forward vocal sibilance, bright treble, and excellent treble extension. It can be customized into 36 sound signature combinations, which is why we say it has 36 different sounds. It has 3 sub-bass, 3 bass, 3 mid plus treble tuning option, 3 times 3 times 4 equals 36. FLC8s was first released to Chinese market in October 2014. In the past 2 years, more and more people have recognized its advantages. Its recognition now extends beyond China, with reviews featured on the front page of headline and an impression thread with over 5,000 posts. With 36 sound signature combinations, we can honestly say it's the most customizable IEM in the world. Today, I'll introduce it to you comprehensively, explaining the acoustic theories and how they work. Before introducing the technologies, I want to emphasize that all technologies have been patented, all rights reserved. Now, I'll introduce how to adjust the sub-bass. And we name the technology as APRV, Adjustable Pressure Relief Valve. Before introducing the technology, I need to introduce 3 concepts first. 1. Sub-bass. Sub-bass is the sound between 20 Hz and 80 Hz. We name it as ultra-low frequency in our menu. 2. Wavelength. Wavelength is the distance between repeating units of a propagating wave of a given frequency. 3. Frequency. Frequency is the number of occurrences within a given time period, usually within 1 second. The relationship between sound wavelength and frequency is wavelength equals sound speed divided by frequency. Sound speed near the Earth is about 340 meters per second. From the equation, we know that for a given sound wave, if its frequency is lower, its wavelength is longer. For example, an 80 Hz sound, its wavelength is 4.25 meters. A 20 Hz sound, its wavelength is 17 meters. To use an analogy, if a sound is a man, its wavelength is the man's legs. Low frequency waves are long legs. They are very easy to pass obstacles and are very easy to escape. Now, back to our topic. We know that low frequency waves are easy to escape, so we use the characteristic to adjust the sub-bass. Now, please see the 3 sub-bass plugs included with FLC8s. The red plug has no hole. The gray plug has a small hole. The clear plug has a big hole. With the red plug installed, the chamber is sealed. No sub-bass wave can escape. Sub pressure in the chamber is the highest, so it gets a strong sub-bass. With the gray plug installed, a little amount of sub-bass wave escapes. Sub pressure in the chamber is medium, so it gets a medium sub-bass. With the clear plug installed, more sub-bass escapes. Sub pressure in the chamber is weak, so it gets a weak sub-bass. Here are the frequency responses of the 3 sub-bass plugs. This green curve is from the red plug. This red curve is from the gray plug. This blue curve is from the clear plug. Above is the sub-bass tuning technology, APRV. Now, I'll introduce how to adjust the bass. Bass is the sound between 80 Hz and 300 Hz. We also call it low frequency sound, and we name the technology as ECS, Emission Control System. This technology is very complicated. I need to introduce how a dynamic speaker works first. When music signal goes through the coil, it generates a magnetic field. The magnetic field interacts with the magnet of the speaker, which causes the diaphragm to vibrate. The vibrating diaphragm makes sounds. When the diaphragm vibrates, the space behind it, this red area, changes. The air is sucked in or pushed out of the space. Now, let's put a filter over the rear end of the speaker to control the air flow, so the air cannot be sucked in or pushed out freely. Just like there was an unseen hand to grabbing the diaphragm, so it cannot vibrate freely, which causes the amplitude of the diaphragm to drop down. So there is less bass quantity. If we put a low density filter over the speaker, the air still can flow freely. So a strong bass is produced. If we put a high density filter over the speaker, the airflow is strictly controlled, so a weak bass is produced. This is the way we used to adjust the dynamic speaker. Now, let's check the construction of the earpiece. Here is the speaker with a low density filter on it. Here is the bass plug with a filter on it. Here are the bass plugs. The clear plug has a medium density filter. The gray plug has a low density filter. The black plug has no filter. With the clear bass plug installed, that's low density filter plus medium density filter equal high density filter. A weak bass is obtained. With the gray bass plug installed, that's low density filter plus low density filter equal medium density filter. A medium bass is obtained. With the black bass plug installed, that's low density filter plus no filter equal low density filter. A strong bass is obtained. Here are the frequency responses of the three bass plugs. This blue curve is from the black plug. This green curve is from the gray plug. This red curve is from the clear plug. Above is the bass tuning technology, ECS. Now, I'll introduce how to adjust the mid and the treble by crossover technology. And we name the crossover technology as MFO, mid frequency overlaying. Mid is the sound between 300 Hz and 3000 Hz. Is the vocal frequency. Treble is the sound over 3000 Hz. Here is the basic circuit diagram of FLC8s. We can see there is no electronic filter between the dynamic speaker and the dual armature. This design provides a better coherence. From the circuit diagram, we can see the dynamic speaker and the low frequency armature have the same polarity. But the high frequency armature is different. It has a reverse polarity. This reverse polarity high frequency armature is very important because it can offset some amount of treble at about 5 kHz, reducing sibilance. We introduced wavelength before. We know that wavelengths are just like the legs of a sound. Bass has long legs. On the contrary, treble has short legs. It's not easy to pass obstacles. So we put a filter in the channel to block some treble. Let's check the construction of the earphone. Here is the filter for the armatures in the channel. This is the way we use to adjust the treble. Now, I'll introduce our unique crossover technology. I think it's a simple but very artful device. From this picture, we can see the channel of dynamic speaker and the armatures are separate. Sounds from the dynamic speaker go through a hole to add to the sound of armatures. This little hole is very common, very unnoticeable, but it's the key of the technology. We use different sizes of holes to control the sound. If the hole is bigger, more mids from the dynamic speaker can go through to add to the mids from the armatures, making the vocal more forward. At the same time, more treble at about 5 kHz can go through to offset the treble from the armatures, decreasing the sibilance. Let's check the green nozzle. We can see there's no filter in the nozzle, so no treble is blocked. The hole at the side of the nozzle is small, so less mids from the dynamic speaker can go through to add to the mids from the armatures. At the same time, less treble at about 5 kHz can go through the hole to offset the treble from the armatures. So overall, the characteristic of the green nozzle is vocal is not so forward. Sibilance is stronger. Treble is bright. It can be used to listen light music, like piano music and string music. Let's check the gun blue nozzle. We can see there's a low density filter in the nozzle. A little amount of treble is blocked. The hole is small, so less mids from the dynamic speaker can go through to add to the mids from the armature. And at the same time, less treble at about 5 kHz can go through to offset the treble from the armatures. So the sound of the gun blue is bright and balanced. Now let's check the blue nozzle. We can see there is a medium density filter in the nozzle. So a big amount of treble is blocked, making the sound dull compared to the other nozzles. Let's check the golden nozzle. We can see there's a big hole at the side of the nozzle. In fact, it's bigger than any other nozzles. The big hole allows more mids from the dynamic speaker to go through to add to the mids from the armatures. At the same time, more treble at about 5 kHz from the dynamic speaker can go through to offset the treble from the armatures. So the golden nozzle have forward vocals with less sibilance. Is the vocal nozzle. Here are the frequency responses of the technology. This red curve is from the golden nozzle. This green curve is from the gun blue nozzle. This blue curve is from the green nozzle. This purple curve is from the blue nozzle. Above is the Mixed Plus Treble Tuning Technology, MFO. Now, I'll introduce the cable, which is made of 7N single crystal copper. Copper purity in the cable is over 99.99998%. Single crystal copper has no crystal border inside, so there is no signal loss. There is 400D Kevlar inside the conductor, ensuring a long lifetime of the cable. The cable was braided by a self-designed machine. No solder joints in the wire split, ensuring smooth signal transmission. This is all I need to introduce. Thanks for your time.